Okay, so that's our first card. Now, Alex, I got some cards for you. Count out 12 pieces of paper. Get the rest of them. All right, now our second card is going to look like this. And this is the equation y equals x, and it is called the identity function. You don't need to put the word function on there if you don't want to, if that just makes it more stuff. But feel free to if you want. It is the identity function. So you've got this diagonal line drawn. The equation is y equals x, and the name of it is the identity. And remember, we're putting the picture on one side and the name and the equation on the other side. Okay? Next card. You have a picture that looks like this. Its equation is y equals x cubed, and it's called the cubing function. Caught up? So far, so good. Next one is a V shape. Anybody remember what that is when it's a V? It's an absolute value. So this is the absolute value function. It looks a lot like the squaring function, but the squaring function is rounded, and the absolute value is a stripped pointy V. I'm going to start erasing now to make room. Next we have this, which is the equation y equals the square root of x, and it's called the square root function. Square root function is that one right there. That's the picture. Then we have this one, which is y equals e to the x. It is called the exponential function. It's the exponential. Notice I did label a point on there. I want you to label that point. It's the point 0, 1. It's the only point I've labeled so far. Clearly, some of these others, though, have the origin, right? You recognize that. You got the origin in some of these pictures. Now we have this one, and that's the point 1, 0, and this is the logarithmic function. Remember ln, that's an ln, not a 1n, that's an ln. You remember that from last year in natural logarithms. So this is what a logarithm looks like if you draw a picture of it. My least favorite, the one I do not like at all. Have you seen something like this before? This is called the greatest integer function. These are brackets, and it's called the greatest integer function. It's a step function. It goes up by steps. Now we have one that looks like this. You've probably seen that shape before. That's the equation y equals 1 over x, and it's called the reciprocal function. The one that probably has the hardest equation. It's called the logistic function, and it looks like this. You have 2 cards left. Tell me I counted right. We have 2 left? Yeah. Okay. Oh, you should just have 2 left. I think I've done 10 of them. And now, for the last 2, now this is sine. We say that sine. Y equals sine x. So this is called the sine function. There's the equation, not sin. Don't say sin, it makes you sound goofy. Y equals sine x. It's called the sine function, and it looks like this. Look where I'm starting. It goes up and down, just like that. That's called the sine function. And it does keep going. I'm just not going to keep going, but it does keep going. Now the reason I wanted you to pay really close attention to where I started was because the cosine function, this is called the cosine function, its equation is y equals cos x, cosine x. Its picture is exactly the same type of thing, but notice where it starts. Do you see the difference between the two? That's going to be a tricky thing for you to remember. The sine goes through the origin. The cosine starts up here. When I start drawing it, I start up high. They both just kind of oscillate between 1 and -1. Lucas, is your hand up? You just stretch. Okay, not much more time. We have to go to lunch. Darn. Wish I could just keep you. No one's hungry, right? Would you rather stay? All right, so everybody's got all 12 cards done. Yes, April.
Will I always start at 1 and -1?
Yes.
Okay.
Well, this, when we draw cosine functions, until we get to the chapter where we start messing with them, it's always going to start at 1.
Okay.
Okay, always. And the sine is always going to start here. So we need to get started memorizing those right away, because there's 12 of them. We aren't ready yet to do any problems with them. Have we started 1.1 with you guys?
No.
Well, we're going to do that right now. I don't know where you think you're going. We still have... No, we don't. Not in this class, we don't. If you have a nicer teacher than me, but we're going at 12:20. I have it all mapped out. All right. This is worth the tag. You have in your possession 2 sets of note sheets. The one that's almost completely filled in, the old one, the one that we just took a test over. If you can find that, would you get it out? Not your practice test. Put those away. We're done with those. Get out your note sheet, the one we've been working on and started with, because there are 2 problems on the very last page at the bottom.
They look like that.
That's the new one, so hang on to that. We're going to go to that one next. That's the old one that we've been working on.
I think that's it.
It says 1-1, page 81. So on the very last page at the bottom, it says 1-1, page 81. And then it says we need to do problem 12A and B. Now, as soon as we get these 2 problems done, we're going to go. So, listen, if you can't find it, just get out another piece of paper, label it page 81, 12A and B, and 20. Those are, as soon as we're done with that, we're going to lunch, okay? So, if you have your textbook, which you may not have brought today because it was test day, so I'm okay with that, but if you have it, because I never go anywhere without my book, look at, actually it's page 82, I'm sorry, page 82. Number 12A and B. It refers to the table at the top of the page. Oh, does no one have a book? Okay. Because you really need to look at the table to answer the question. What's happening in the table is, the table tells you for a given year, like the first one's 1954, how many females are, the percentage of females that are working and the percentage of males that are working. Notice in 1954, 32% of women worked and 83% of men worked. Does that make sense to you? In 1954, which was even before I was born, back then, what? Most of the women stayed home, right? Took care of the house, raised the kids. Compare that to 2004. 57% of women are working and only 72% of men are working. So what trends do you notice? Question A says, what's the trend? What's happening to the women? More and more women are getting out in the workforce. What's happening to the men? fewer and fewer are getting out into the workforce. Any of you raised by a stay-home dad? All your dads work, Clayton, at one point? There are more and more men. I know a couple of years that I worked part-time, I did daycare part-time, and it would be amazing when I take the kids somewhere, like a library or whatever, how many dads would be there with them. It's pretty cool, actually. Okay, and then number 20, last question. A bakery sells a 9 by 13 cake. Has nothing to do with this problem. It's a whole brand new problem. We have a 9 by 13 cake. And we're selling it for the same price that we're selling an 8-inch diameter round cake. So somebody's got a birthday, you're gonna go get them a cake, you walk in, you can spend the same money for this one as this one. Now, here's the difference. This one is a layer cake. So this is twice as thick as the regular layer cake. This one's just a single layer. This one has 2 layers. And we want to know which one's the best deal. Alright? So what do we need to do to figure that out? How do we figure out where we get the most cake? What would we do to find out how much cake we get here? What would we do? Find the area? That's a thought. Sometimes I do want to find the area, but I think this time I want to find volume, because volume is not just how much I see, but it's how much I actually have. Anybody know how to find let's say this is 1 inch thick. They didn't tell me how thick it was, so let this one be 1, and then this one will be 2 inches thick, because it's twice as thick. Anybody know how to find the volume if it's 9 by 13 by 1?
Like 1/2.
Some of the formulas have a 1/2. This one doesn't. Length times width times height. So 9 times 13 times 1 is 117 cubic inches. So I would get 117 cubic inches. This is problem number 20. 117 cubic inches of cake if I bought this kind. Now, what if I bought the other kind? It's not a box like this. What shape is this going to be? That cake, imagine that cake. What shape is that going to be? Well, certainly it's got a circle on the bottom and a circle on the top. What shape is this? A cylinder. We're almost out of time, so I'll give you the formula. V equals pi r squared h. Pi r squared h. What's my radius? No, that's my diameter, so it would be 16, 4 squared. My height's 2, and if I type in 32 pi on my calculator, it's 100.5. 100.5 cubic inches. So the cake I want to buy, if I want to get the most for my money, is the rectangle. Right? Okay, so I'll see you tomorrow and we will pick back up where we left off. All right, have a great day. Oh, you leave before this class starts?
Yeah, we have to leave.
All right, then you better watch the video. I knew you leave early. I didn't know if it was